Hey everybody, now that you've had a chance to take a look at all the Petri dishes and you've had an opportunity to try to figure out if these are elements, compounds, mixtures, atoms, or molecules, that type of thing, we'll go over the answers. And I think what I'll do is in the comment section, I will put the formulas, because sometimes what I do in class is that I actually teach the formula writing as a separate skill, which it is. So let's go ahead and start. So for letter A, all of these washers are connected to each other. So this is a molecule. And all of these are the same, so what you're looking at is just molecules. They're the same molecule. Each of these is equivalent to each other. So that since they're the same molecule, I would say this is homogeneous. And then as I look at this, it's all made of one thing. So this would be an element. All right, so that's letter A. For letter B, we kind of need to look at all these kind of individually. Atoms would be alone. There's nothing alone here, so everything has something connected. Even these two are connected to each other. So all of these are molecules. However, they're not the same molecule. These are all different from each other. So what we have is that we have heterogeneous. I would call this heterogeneous, and they're all different. And then I would say this one here, because these are made of the same thing, would be an element, but these are all have different things connected to each other. So I would say this is a mixture of element and compounds. All right, that's letter B. For letter C, let's check out what we've got. So all of these are the same, so we can just really look at one of these. And so this is a molecule made of more than one thing. These are all the same molecule, so I would say as a group, this is a homogeneous group because these are all the same. And then in terms of element, compound, or mixture, this is a compound that's made of different things, and these are all the same, so we're looking at the same compound. All right, for letter D, what we've got is that all these bolts are separate from each other. So these are atoms, these are connected, so it's molecules. So you have atoms and you have a molecule. Now, when you have atoms and molecules, it has to be heterogeneous because an atom is by definition different than a molecule. So this would be heterogeneous, and I would say these are elements. And then I would say this would represent an element as well because it's made of the same thing. So we're dealing with two different elements. I would say I have a mixture of elements. For letter E, we've got these are connected and these are connected. So they're both molecules. They're different molecules, so it's heterogeneous. So I would say molecule, and I would say heterogeneous because they're different. And then this is an element because it's made of the same thing. And then this is a compound made of different things. So I would say you have a mixture of an element and a compound. For letter F, all of these are alone. They're not connected. So if they're alone, we call them atoms. They are different atoms. So I would say this is a heterogeneous. And so they're still separate on a big scale. I would say these are elements, but they're not all the same elements. So I'd say I have a mixture of elements. Okay, that was letter F. So here's G. Okay, these are connected, so these are molecules. So the yellow ones are molecules, and then the blue ones are alone. So I would say I have atoms and I have molecules. So then, since they're different from each other, it's heterogeneous. And so I would say I have a mixture of elements. So the irons, the Fe's, these are elements. And then these are made of the same thing, so these are elements. So I'd have a mixture of elements here. So G to H, okay. So these are connected, and these have connected pieces. So these are molecules, but they're different from each other, so it's heterogeneous. If it's heterogeneous, it's got to be a mixture. So if it's a mixture, this is a compound and this is an element, I would say I have a mixture of a compound and element. Letter J here, these are all really the same. So this has pieces that are connected, so they're molecules. They're the same molecule, so they're going to be homogeneous. And then these are all the same as different things connected. So this is a compound and these are all the same. So you're just looking at a compound here. All right. Hopefully that was kind of clear. One of the big sort of takeaways here to help clarify things usually is the idea that if something is heterogeneous, it has to be a mixture. But once you decide it's a mixture, then you need to think about what type of mixture. So for instance, if I kind of go back to some of these, so if I went back to letter D, I'm going to zoom out here a little bit. If I went to letter D, this is a mixture of different elements. If I had go to letter E, we said this is a mixture of an element and a compound. And then if we went back to, for instance, not sure if we have an example of a mixture of compounds, but let's just say we were looking at letter B here. Let's say we're looking at letter B, but we didn't have this one. I would say we have, so if we didn't have this connection here, this piece, I would say that this is a mixture of different compounds. All right? Hopefully that's clear, everybody. We'll take questions in class. Thanks for watching.